Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 16 video on the topic of floating and sinking of a solid in a liquid, where I will discuss case 3 when a body with a density uh, which is which is lower than the density of the liquid will float. Uh, in the previous two videos, that is part 14 and 15, I have discussed the other two cases where the body of the density of the body was equal to and greater than the density of the liquid, and what happens. If you have not watched those two videos, then please watch them as they are very crucial to understand. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 16 video, where I will discuss what happens when a body of density which is less than the density of a liquid is immersed in the liquid. Okay, so as usual, I have the diagram. We can see that a body is immersed in a liquid, and as per the Archimedes Principle, the weight of the body is acting vertically downwards, and this is the weight acting vertically downwards on the body, and this is the buoyant force which is acting vertically upwards on the body, and as of now, you are already familiar that the buoyant force is equal to the weight of the displaced liquid, and the volume of the displaced liquid is equal to the volume of the immersed part of the solid. Okay, so I have assumed the total volume of the body to be VML, the density of the body to be ρ1 gram per centimeter cube, the density of the liquid to be ρ2 gram per centimeter cube, and the volume of the immersed part of the body to be V dash ml. Now, it is said that when the density of the body is less than the density of the liquid, it floats. Let's see why is it so. Now, why a body floats? What is the condition that a body floats? A body will float when there is no net force acting on the body. A body floats means that it is not moving either downwards or upwards. That means that no force is acting on it either downwards or upwards. So I can say this implies that the net force which we have discussed in previous videos to be W dash, net force acting on the body, or the net weight or apparent weight of the body when it is immersed in the liquid, is 0. So this implies, what is the apparent weight? Apparent weight is nothing but the weight of the body minus the buoyant force. This is equal to 0, and of course this implies that the buoyant force is equal to W. It is a known fact, we have already understood this fact, that when a body floats, the buoyant force has to be equal to the weight of the body. Now let's see why the buoyant force is equal to the weight of the body when the density of the body is less than the density of the liquid. Okay, so what is buoyant force? The buoyant force we know is the weight of the displaced liquid. And what is weight? Weight is nothing but the mass in mass gram force. If we consider the mass to be in gram, so what is the mass of the displaced liquid? The volume of the displaced liquid is the volume of the immersed part of the solid, which is V dash. Okay, and the density of the liquid is V ρ2. So this much gram is the mass of the displaced liquid. So the buoyant force, which is equal to the weight of the displaced liquid, will be V dash. This is V dash ρ2 gram force. And what is weight? That is weight of the body. We have assumed VML to be the total volume of the body, and ρ1 gram per centimeter cube is its density. So the mass of the body is volume into density, that is V ρ1, this much gram. So we can say that the weight of the body is this much gram force. So now we can say that when if the condition is if the for the condition of the body floating is always the buoyant force is equal to weight. Let's see what we get from this fact. What information we get if the buoyant force has to be equal to the weight. So the buoyant force is V dash rho 2. This much should be equal to V rho 1. Okay. Now, okay. Now, can this be true? When we know that rho 1 is less than rho 2, when rho 1 is less than rho 2, and of course, V dash is the volume of the partially immersed liquid. So we must understand that V dash is greater than 0, but it is less than the total volume of the body. Now, what does this mean? This means that, let's see, if this is to be has to be true, let's see what V dash is. V dash is coming out to be V multiplied by rho 1 by rho 2. Rho 1 by rho 2. Now, so we are getting V dash to be V multiplied by rho 1 by rho 2. Can this be true? Can V dash be equal to V multiplied by rho 1 by rho 2 for whatever value of rho 1 and rho 2 is, provided that rho 1 is less than rho 2? Can this be true for any value of V dash? If it is so, then we can always say that for some value of V dash, Fb, that the buoyant force will be equal to the weight, and in that case the body will float, and the body will float with V dash ml of V dash volume of the body being immersed in the liquid. Okay. Now let's see what is rho 1 by rho 2. We know that rho 1 is less than rho 2. If I divide both sides by rho 2, I get rho 1 by rho 2 is less than rho 2 by rho 2. This implies that rho 1 by rho 2 is less than 1. So the fraction, the rational, the number rho 1 by rho 2, this part is less than 1. So I can say that this implies that V dash will be always less than V, since we know that rho 1 by rho 2 is a value which is less than 1, but of course it is greater than 0. Of course it is greater than 0 because rho 1 and rho 2 both are 0, both are greater than 0. Sorry, rho 1 by rho 2 is greater than 0 but less than 1. If this is so, then V multiplied by rho 1 by rho 2 should be less than V, which is quite possible. We know that V dash is always less than V. So it is quite possible that it is so we can see that when rho 1 is less than rho 2, we are having a value of V dash which is less than V, which is quite possible. Now, so we can say that for some value of V dash, definitely for some value of V dash which is less than V, and the fact that rho 1 is less than rho 2, we are indeed having that Fb is equal to W, which that means the body will float. Now the important thing to note is that we understood that the body will float because we can see that for some value of V dash which is less than V, we will get Fb equal to W, which means the body will float. The important thing to note is that what is V dash? What is V dash? V dash is rho 1 by rho 2 multiplied by V, This is the important thing to understand. That is, V1 is a part of V. What is that part? A fraction of V. That is a fraction of the total volume of the body. What is that fraction? That fraction is rho 1 by rho 2. So I can say that when rho 1 is less than rho 2, when rho 1 is less than rho 2, then the body will float, and rho 1 by rho 2, this much part of the body will be immersed. This much fraction of the whole volume will be immersed in the liquid. This is the important information to note in the liquid. So when rho 1 is less than rho 2, we are seeing that the body will float, but the important thing is that how much part of the body will float, and that fraction, that part is nothing but rho 1 by rho 2. So rho 1 by rho 2 fraction of the whole volume of the body will be immersed in the liquid, and the body will float. This is the important catch. I hope I was able to explain why the body will float in a liquid where the density of the body is less than the density of the liquid. So I have already covered the three cases regarding the floating of a body, the floating or sinking of a body of a solid in a liquid, depending on the relative values of the densities. Now, since all these cases are based on some specific values of the density of the solid and the liquid, you must understand that if the relative density of the solid and liquid is given, then also you should be able to tell whether the body will sink or float, because from the relative density of a solid or liquid, you can easily get their density in gram per centimeter cube or even in kilogram per meter cube. In the next, I will try to frame some questions based on these case 1, case 2 and case 3, that is floating and sinking of a solid in the liquid, that is based on these previous 3 videos, because this is a very crucial concept to understand. You must have a good clarity of the concepts so that you can understand, you can solve any kind of conceptual problems based on these 3 cases. So probably the next 2 videos will be solving problems, numericals. I will create 2 sets, 5 problems per set. So these videos are coming soon, so please stay tuned. I will end the video here, and once again, if you find this video beneficial, please like it, share it with your friends, and please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So thanks for watching, and until the next video, take care and bye.